Now, we're asked to use properties to help simplify the expressions, and remember the properties that we've looked at so far: the identity property, commutative property, associative property, and distributive property. Now, as I do these examples, I'm going to go through and do each individual step and show you how these properties are actually working. As we get better at this, we'll be able to take shortcuts. In other words, we'll be able to add these like terms without actually writing out all the properties, but it's important that we understand the mathematics behind it, all right, and why this stuff is working, all right. But as we get better at it, we'll be able to do this without actually having to write each step. But for right now, we want to write out the steps so we can begin to understand how all these properties are working together in order for us to add these like terms. Okay, so as I look at this first expression, I notice that this is a variable factor with an exponent of 1, x to the first, and so is this. So these are like terms. So this is not simplified, so we want to simplify it. So we're going to do what we did before, and that is use the distributive property in reverse. The common factor is x, so we're going to factor out the x. Okay, we're going to use the distributive property in reverse, and so we're going to divide this by x, and we know that x divided by x is 1, so that leaves me 3 times 1, which is 3. And then I have to divide this term by x, and x again divided by x is 1, so that leaves me 4 times 1, which is 4. That's the identity. So by factoring this out, I then have 2 numbers inside, which I can go ahead and simplify now using order of operations. PEMDAS will simplify the parentheses, so this leaves me x7. Now I can go ahead and multiply, because order of operations, and 7 times x is 7x. So the simplified version of this final version, algebraic expression, has no like terms. I've taken an expression that had like terms and turned it into one that doesn't have like terms using the distributive property in reverse in order to get some terms inside that I can add together. All right? And again, I'm writing out all these steps. As we get better at this, you'll, I'm sure, notice the shortcut, and it's going to be okay to go ahead and do that. But again, I want you to understand the mathematics behind it, because even though you may know how to do this, doing the shortcut, on a quiz or a test, I will ask you to show all the steps in how you're doing your shortcut. So you want to practice this as we're moving forward. Okay, in the next one, again, I notice we have like terms, and because I have like terms, this variable factor is always going to be in common, so we're going to factor that out. So if I factor out the x, that means I have to divide each of these by x. X divided by x is 1, so that leaves me a 1. And then dividing this term by x, that leaves me another 1, and so I end up with this. So then I can simplify my parentheses, 1 plus 1, and then I can multiply, and so I end up with 2x, so the simplified answer is 2x. Okay, so this is the distributive property in reverse. When we get 1 here, then we can add the parentheses, it gives me 2, and then we're doing order of operations, we multiply 2 times x and get 2x. All right, let's look at this last one here, because we're going to use another property here. Now here I notice that my like terms are kind of spread apart. I've got a 2x here and a 5x here, which are like terms because their variable factors are exactly the same. And I have a 3y and a 2y, which are like terms. So I'm going to use the commutative property and change these around so that my like terms are together. So I'm going to go up here and do this. And so I can put my 2x with my 5x, and then I can put my 3y with my 2y. So I've I've used the commutative property to put those together. And I can even use my associative property then to group these two together and group these two together to kind of begin now adding my like terms. So within here I have a common factor of x, so I'm going to factor that x out. Okay, so I'm going to divide this by x, so x divided by x is 1, and then 2 times 1 is 2. Divide this by x, x divided by x is 1, and then 5 times 1 is 5, and so I have this here. And then I'm going to do the same thing over here. Here my common factor is y. So I'm going to factor out the y. So I'm going to divide this by y. Y divided by y is 1, and 1 times 3 is 3. Y divided by y here is 1 again, and 2 times 1 is 2. And so I've distributed in reverse my common factor. Then I'm going to go ahead and simplify my parentheses. So this is going to be x times 7 plus, don't forget to bring this down, and then I'm going to have y times 5. Okay, then I can simplify this further, so this is going to be 7x, and then this is going to be 5y. Okay, and now I have an expression 7x plus 5y. Now these are not like terms. This has an x and this has a y. So this is my final simplified answer of 7x plus 5y is this algebraic expression now simplified. Okay, so we want to be able to identify like terms, and then we use the distributive property in reverse to add those like terms. And again, I want you to be able to go through these steps as you're adding like terms. Now the shortcut to this, real quickly, I'll show you, is if you have like terms, you simply need to just add the coefficients. Okay, it is essentially what ends up happening. We factor out that and we end up adding the coefficients and then multiplying them together. So the shortcut would be to simply identify your like terms and then add the coefficients. So the 4 and the 3 is 7, and then we keep the common factor. Okay, the common variable factor. So that's the shortcut. You remember we factored this out. We factored out the x, then we added the coefficients, and then we multiplied that out and ended up with this. So the shortcut would be to just add the coefficients of the like term. So here we have a 1 in front of here and a 1 in front of here. Okay, that's the identity property. 1 times x, and 1 times x is still x. And so I can add the 1 and the 1 and arrive at 2x. Here I can identify again my like terms and simply add the coefficients. The 5 and the 2 is 7. And then these like terms of y, the 3 and the 2 is 5y. And again, these are not like terms. There's nothing else I can do. And so I end up here. Alright? So again, the shortcut is okay to use. Go ahead and use that. But just be aware that on a quiz or a test, I will ask you to step by step show me how this adding of the coefficient actually works, because we need to understand the mathematics behind the shortcuts that we're using. So we want to be able to do that.